What if a camera could recognize you before you even realized it saw you? Not just your face, but your age, your mood, your identity. What if it could scan a crowd of 10,000 people and find one person in seconds? This isn't science fiction. This is AI facial recognition. It's unlocking phones, boarding airplanes, tracking criminals, monitoring cities, and it's evolving faster than most people realize. Today, we're diving deep into the advanced technology behind AI facial recognition, how it works, how accurate it really is, where it's being used, and the serious questions it raises about privacy and the future of society. Because this technology doesn't just see faces, it changes everything. For decades, identifying someone required physical documents, IDs, passports, fingerprints. The process was slow, manual, and entirely dependent on human judgment. But today, your face is your password. Apple uses facial recognition to unlock devices instantly. Airports worldwide are adopting biometric scanning to replace boarding passes. Law enforcement agencies analyze surveillance footage in real time to track suspects across cities. And countries like China have integrated facial recognition into large-scale public monitoring systems, covering millions of cameras across thousands of urban centers. The technology is no longer experimental. It is embedded in daily life, often without people even noticing. But how does a machine look at a face and determine identity with shocking accuracy? To understand where we're going, we first need to understand how it sees. Section 1. How AI facial recognition actually works. AI facial recognition isn't just matching pictures, it's mapping geometry. Here's what happens in milliseconds. First, a camera detects a face within an image or video frame. The system isolates the face from the background, adjusting for lighting and orientation. Then, advanced algorithms analyze specific facial landmarks, distance between the eyes, shape of the jawline, length of the nose, contours of cheekbones, depth around eye sockets. Every human face contains approximately 80 nodal points, unique measurable features that distinguish one person from another. This creates a unique mathematical representation called a face print. Think of it like a digital fingerprint, but for your face. This face print is then converted into a numerical code and compared against a stored database in fractions of a second. Modern systems use deep learning neural networks trained on millions, sometimes billions, of facial images. These networks learn to distinguish subtle differences between faces, even identical twins. The AI doesn't memorize, it learns patterns, and the more data it processes, the better it becomes. Section 2. The Deep Learning Breakthrough. The real revolution in facial recognition came with deep learning. Earlier systems relied on basic pattern matching. They struggled with poor lighting, angled faces, expressions, and aging. A simple change in hairstyle or the addition of sunglasses could confuse the entire system. But deep convolutional neural networks changed everything. These systems analyze faces layer by layer. The first layers detect basic features, edges and contrast. Middle layers identify textures, shadows, and depth. Final layers assemble a complete facial map, capable of distinguishing thousands of unique identities. The process mirrors how the human brain recognizes faces, but at speeds no human can match. These networks can now recognize someone from a partial side profile, low-resolution video, even photographs taken years apart. Some systems can identify someone wearing glasses, hats, facial hair, or minor disguises. The most advanced models process facial data in under 100 milliseconds, faster than a human blink. That's the power of modern AI. It doesn't just detect, it adapts, it improves, it never forgets. Section 3. Accuracy. How good is it really? Top-tier facial recognition systems now claim accuracy rates above 99% under ideal conditions. The National Institute of Standards and Technology, NIST, regularly benchmarks facial recognition algorithms. In recent evaluations, the best-performing systems achieved error rates below 0.1% in controlled settings. In environments like smartphone authentication, where lighting, distance, and angle are consistent, the results are remarkably reliable. But real-world scenarios introduce complexity. Lighting conditions, camera quality, and angle still matter. Crowded environments create variables. Weather, motion blur, and partial obstructions challenge even the most advanced systems. and researchers continue working to reduce bias in datasets to ensure equal performance across different demographics. The technology is powerful, but it's not perfect, and that distinction matters more than most people realize. Section 4. Where it's being deployed. Let's look at how this technology operates in the real world today. Smartphones. When Face ID was introduced on the iPhone X in 2017, it marked a fundamental shift toward biometric security. Instead of typing passwords, users simply glance at their device. A structured infrared light projects over 30,000 invisible dots onto the user's face, creating a precise three-dimensional depth map. This makes it nearly impossible to fool with photographs or masks. Airports and travel. Airports worldwide now use facial recognition for boarding gates, passport control, and security checkpoints. Dubai International Airport introduced biometric tunnels. Passengers walk through a corridor lined with cameras that verify identity without stopping. No documents required. No human interaction. Travelers clear security in seconds. Law enforcement. Police departments across various regions use facial recognition to identify suspects, search surveillance footage, and locate missing persons. Some systems scan video feeds in real time and flag matches instantly. In certain cases, the technology has helped identify suspects within hours of a crime, a process that previously took weeks. Retail and commercial use. Some retail environments experiment with identifying repeat customers, analyzing shopper behavior, and preventing theft. Stores have tested systems that recognize known shoplifters as they enter. Though this application remains controversial and legally challenged in several jurisdictions. Financial services. Banks use facial biometrics for identity verification, fraud prevention, and secure transactions. Mobile banking apps increasingly require a face scan before authorizing large transfers. Your face may soon replace passwords, PINs, and security questions entirely. Section 5. Real-time recognition at scale. Perhaps the most advanced application is real-time crowd scanning. Some AI systems can process thousands of faces per minute, cross-reference national databases, and identify flagged individuals within seconds. In high-density areas, stadiums, transit hubs, city centers, this creates a digital awareness layer over public spaces. During major events, systems can monitor entry points, flag persons of interest, and alert security teams before an incident occurs. Fast, automated, scalable, and operating continuously without fatigue or distraction. That level of capability fundamentally changes the nature of surveillance. It transforms cameras from passive recording devices into active identification systems. Section 6. Beyond identity. Emotional and behavioral analysis. Facial recognition is evolving beyond identification. New AI systems analyze micro-expressions, eye movement, and muscle tension to estimate emotional states, stress levels, and attention focus. A smile that lasts 0.4 seconds versus 1.2 seconds can indicate the difference between genuine happiness and social politeness. Some airports have reportedly tested emotional analysis at security checkpoints, attempting to identify passengers exhibiting signs of extreme stress or deceptive behavior. While still developing, this area, often called effective computing, pushes facial recognition into psychological territory. The machine doesn't just know who you are, it begins to interpret how you feel. And that's where the ethical debates intensify. Section 7. The privacy debate. With great intelligence comes serious questions. Who owns your facial data? Can you opt out? How long is biometric data stored? Who has access to it? Unlike a password, you cannot change your face. If biometric data is compromised, it cannot be reset. There is no recovery option, no forgot my face button. The European Union's General Data Protection Regulation, GDPR, classifies facial data as sensitive biometric information requiring explicit consent. Several cities in the United States, including San Francisco, have banned government use of facial recognition technology. Others continue expanding it without restriction. The tension lies between four forces that rarely align: security, convenience, privacy, and freedom. And there is no universal agreement on where the line should fall. Section 8. Bias and fairness. One of the most significant technical challenges has been algorithmic bias. Early systems performed unevenly across different demographic groups due to imbalanced training data. Certain populations were misidentified at significantly higher rates than others. A landmark 2018 study by MIT researcher Joy Bolamwini found that some commercial systems had error rates up to 34% for darker-skinned women, compared to less than 1% for lighter-skinned men. Today, major AI developers invest heavily in improving dataset diversity and fairness testing. Accuracy improvements are ongoing, but transparency and oversight remain critical. Because when AI identifies people, mistakes carry consequences. A false match isn't a software glitch. It's a person's life disrupted, a wrongful detention, a denied boarding pass, a frozen bank account. The stakes are human, and the solutions must be equally serious. Section 9. The future. So where is this technology heading? Future developments may include seamless authentication without user action, continuous biometric verification throughout daily interactions, integration with augmented reality systems, and smart cities with AI-driven identity layers embedded into infrastructure. We may see environments where doors open automatically when they recognize you, cars start without keys, homes personalize lighting, temperature, and music based on who enters the room. Retail stores adjust displays based on recognized customer preferences. Some researchers are exploring gait recognition, identifying people not by their face but by the way they walk. Combined with facial recognition, this creates multi-layered identification systems that become nearly impossible to evade. Facial recognition may become invisible, embedded everywhere, not noticeable, but always active, always watching, always identifying. Section 10. The bigger picture. AI facial recognition represents something larger than convenience. It represents a fundamental shift in how identity works in a digital world. For centuries, identity was proven through documents, papers that could be forged, stolen, or lost. Now, identity is becoming biological, permanent, inescapable. Your face is data. Your presence is trackable. Your movements are recordable. And as artificial intelligence grows more sophisticated, the line between security and surveillance becomes thinner with every advancement. Technology itself is neutral, but how we choose to implement it, that defines its impact. The same system that finds a missing child can also track a political dissident. The same camera that prevents crime can also eliminate anonymity. The tool is the same. The intention behind it is everything. The advanced technology of AI facial recognition is one of the most powerful tools ever created. It can protect, it can simplify, it can accelerate, but it can also monitor and influence and reshape the concept of privacy forever. The real question isn't whether this technology will continue advancing. It will. The question is, how will we govern it? How will we regulate it? And how will we balance innovation with fundamental human rights? Because once a society normalizes constant recognition, there is no going back. So now I want to hear from you. Do you think AI facial recognition makes the world safer? Or does it go too far? Would you trade convenience for privacy? Drop your thoughts in the comments below. If you found this breakdown insightful, hit the like button and subscribe for more deep dives into emerging technology. Because the future of AI isn't just about machines learning. It's about how we live alongside them, and that future is already here.